Okay, I'm going to talk about, I think, a really interesting topic, and I'm going to kind of try to connect the past and the present and hopefully the future in a unique kind of a way. A little bit of background on me. My title is VP and Chief Evangelist of AWS. I've been working at Amazon for almost 23 years. I joined in 2002 at the very, very beginning of our efforts to start building and putting web services out for developers. I actually started out on a team called Amazon Associates, and my first job was actually writing Perl scripts to generate reports. Do we have any Perl developers left here? Wow, good, okay. I actually learned, used, and forgot Perl 3 different times in my career, and luckily that was my final time learning and hopefully forgetting it. Been a technologist since I was really, really young. I've always loved all different kinds of technology. I love to make things. I do 3D printing, I do Lego, I do electronics and combinations. Earned a degree in computer science way back in 1985. And in 2010, I actually went back to school and earned a master's degree in communication and digital media. I take my professional development career back to about 1979 was the first time I really got paid to actually build something with code. At that point, I was building in assembly language for the 6502 processor. So that's a little bit of kind of ancient history. These days, as Chief Evangelist, I love to come and speak at AWS community events. So far this year, I've been to Tokyo, I've been to Bangkok, I've been to Bangalore, I have been to Prague, and now here I am in Armenia. I love to get out and speak and meet and chat with the community. I'm going to be here all day, so afterward, if you'd love to come and share a bit of your AWS journey, any questions, so forth, I'll always love to meet our community folks. For 20 years, I wrote the AWS News Blog. I wrote almost 1.6 million words and 3,200 posts for the news blog. I officially retired from the news blog as of last year's reInvent. I figured 20 years was enough to do anything and wanted to actually spend more time traveling and speaking to our community. So that's what I'm doing now. You'll also find me pretty active on social media. You can find me on LinkedIn as my primary channel. When I'm not traveling, I spend time on Fridays. I do the AWS On Air live stream on Twitch and LinkedIn, where we do some of the latest AWS news. And as I travel, I also really like to get a chance to meet with our customers. Now, I want to try to connect the past. And one of the things I've noticed about technology, and especially I was kind of fortunate to join at a time when there was a lot of change happening in the technology industry. So when I was first started in school, I was actually kind of simultaneously in the past and in the future, where in school, the first couple years of school was actually done on punch cards. Anybody here actually do punch card programming? Oh, wow, awesome. You started, okay, good, okay. So we did punch cards, but at the same time, I had an after-school job in a computer store where I was working with the newest microcomputers of the day. So I was kind of doing the past and the future at the same time. But over the years, I've gotten to work with mainframes and microcomputers and mini computers in between, gotten to use a wide variety of different languages, and kind of given me this kind of, I think, a unique perspective on a lot of the different ways that as developers, we step up to the computer and express our ideas and build applications ultimately. Got to use so many different assembly languages and higher level languages over the years. One of the things I've learned in this field is that there's always something new, and there's always this existing technology. And depending on your personality, you might be more attracted to the new and you want to kind of be a little bit of a risk taker and try the new things, or you might be more comfortable with the current or the past. You've got to be really careful to pick where you want to be on that spectrum. I've noticed if you are too conservative, if you tend to say, well, I will stay with the tried and true and this generation of computers and software and applications, it's kind of good enough and I'm comfortable and familiar with it. That's all right for the present time, but the past comes at you really, really quickly. And if you get yourself a little bit kind of too comfortable, too attached to the current generation, before you know it, that current generation is the ancient history department. And suddenly you find yourself a few generations of technology behind, and it can be very, very difficult to catch up. So I've found that it's really important to understand the past, have a deep knowledge of what's come before, and to understand it and to respect it and say, you know, for each of those times when those things were built, that was good and that was the best we could do at the time, but to also be very, very open and excited about whatever happens to be coming next, and to always also recognize the technology of the present and of the past. Generally, it is very smooth and polished. It's been, all the rough edges have been removed, and it's mature, and it's easy to use, and it's very, very dependable and reliable. The next generation is often not quite there yet. It's still got a few rough edges. It doesn't always work perfectly. Maybe it's missing some features. But as technologists, it's often the best to say, well, I'm going to do my best to be an early adopter and try to bring myself into the future as these new technologies develop. And I've personally found that respecting the past, but being very eager to jump into next generations of hardware, software, methodologies, and so forth has been a really positive thing for me and for my career. One interesting thing about my presentation, so I've traveled to a lot of different countries this year, and I thought it would be kind of fun to use a little bit of AI to customize my presentation. I didn't use AI to write any of the text in this presentation. However, what I did is I tried to kind of customize the images to make sure that they had a little bit of a local flavor, a little bit of a local style to the images. So I used Amazon Bedrock, I used our Nova canvas model, and I used the same basic prompt for each place that I visit, but I usually would just change one or two words in the prompt to ask for something that was a little bit more specific to the area where I'd be traveling. So I'm going to talk a little bit about how we as developers build tools. So I need this kind of an image of some kind of classic folks using tools. So, you know, in order, I went to Japan and Peru and Prague, and now here I'm in Armenia. I used the same prompt. I said, a detailed illustration in a traditional blank style of giants and regular-sized humans using a variety of hand tools, such as hammers and wrenches. And so I got this kind of unique stylistic interpretation. I don't know for sure that looks very Armenian, but it seemed kind of a neat cultural representation. Apologies if it's like wrong or even offensive, but it did seem like a really fun way to customize the presentation. There's nothing, you know, sometimes as a speaker, you're kind of tempted to say, take the presentation and use it over and over and over again. I like to iterate, I like to refine it, and I do like to make sure I customize it a bit for my audience. So that was the Amazon Nova Canvas model, doing that for you. We had some wonderful meetings here yesterday. I was able to meet with your president. I was able to meet with the ministry and the Minister of High-Tech Industries. It was really fascinating and quite the honor to be able to meet with all these folks. Was what I found awesome, your leadership really deeply cares about tech in this country. Super interesting to hear. They're very interested in working with us. We had some great discussions yesterday about strengthening our cooperation. We want to talk about how AWS is going to support your digital transformation. You've got a cloud-first policy for building new applications. And over time, we're going to work to broaden that collaboration. I think one of the amazing things about this means that AWS is going to have a really prominent role in this digital transformation. So the skills, the experience, the content that you build, the work that you do to learn AWS, to create content around it, to help others to learn, my strong sense, that's going to be really valuable to you and to your country in the weeks, months, and years to come. So wonderful to be part of this and see this digital transformation unfolding, and going to be really excited to see how that plays out over the next couple of years. All right, so let's jump in. This is kind of my conceptualization of how developers are feeling these days. We're at a really interesting and I think unique point in time. We're seeing that the practice of development really continues to change, and as we see things like new methodologies and we see these AI-powered coding assistants coming along, on the one hand, developers are really excited by them. They're saying there's a lot of power here. On the other hand, there's this sense of, well, if the coding assistants are going to do a lot of my work, well, where's the space for me? What am I supposed to do? And so I'm really getting the sense from developers in many different places, this bit of uncertainty about their role in technology going forward and how are they supposed to think about, use, and relate to these coding assistants. So I want to kind of try to take a bit of a look at history and maybe give you a sense of how did we get here as an industry to this point where we have these great coding assistants, maybe a little thinking about where we're going to be going with them, hopefully give you a sense of the important role that you all will play in software development going forward, and a couple of my thoughts on how we're going to prepare for this really interesting future. So at this point, as developers, I think we can all agree that we have an incredibly wide range of different development tools, different tactics for approaching and breaking down problems, different approaches for making things happen. And regardless of the way we do it, they're all valid approaches. Also, I think it's important to recognize we have a really diverse set of folks in this field. There's room for the folks that are totally self-taught in technology, where they say, I didn't have the opportunity or the privilege to go to school, but I sat down in front of a computer, I started searching for things, I found some videos, I found some content, I was really personally curious, maybe I found a mentor, but I figured it out all on my own, and I don't have any credentials per se, but I can actually build things, I can make things happen. Totally, totally valid. Kind of in the middle, the more kind of traditional route is you get your computer science degree, you kind of take the standard route to becoming a professional developer. The third one is often kind of you grow up kind of on the more formal side of things. Maybe you have like an applied math degree, take a more kind of mathematical structured approach. I think there's room for everybody in this field, all these as valid approaches. Now, there's so many different ways we might kind of think of ourselves as developers right now, and there are no right answers, but this is kind of my survey just to get a sense of where you all might be. Is anybody still handwriting machine language with zeros and ones here? Nope, okay. I've had a few in past audiences. Anybody actually coding in assembly language right now? Oh, one, okay. 1, 2, 3, 4, okay. That's great, 4, that's awesome. Still one of my favorite things to do. Coding in higher level languages? Most of you, great. Using AI-powered coding assistants? Whoa, that's amazing. Okay, so 41% I decided. Okay, 41% of you, that's actually, believe it or not, as I look at different audiences around the world this year, it's always been somewhere close to between a third and a half of the audience. So that's kind of right in line with the rest of the world. Is anybody using automated reasoning and formal methods to validate your code right now? Okay, you're way ahead of the rest of the world then. It's almost always 1 per audience. I saw 4, so that's really, really cool. Is anybody using quantum computers to do quantum computing things? Okay, we got 1. There's always 1. Okay, there's always been exactly 1 per audience. So totally, totally cool. Absolutely non-scientific. There is no right answer, but just gives me a good sense of where we're all at. And so, only 1 quantum computer? There are definitely more than 1, but there are not thousands at this point. But there's a constant of one quantum computer developer per audience so far this year. Great. Now I want to illustrate an Amazon principle we call the virtuous cycle. I'm going to first talk about it in terms of hardware, but then we're going to apply that to software as well. So this is something that we kind of thought really early in the days of Amazon, this concept of this virtuous cycle. And when I think about this with reference to hardware, we found that every time we build faster and more powerful hardware, not only do we put that hardware itself to use to help our customers, but we can use that hardware to develop the next generation of the actual chips. As we do this, we find that the time between generations of hardware gets shorter and shorter, but at the same time, each generation of these chips we'll talk about gets more powerful and more capable. So here's how we see this virtuous cycle in action. We design a new processor, and then on the current generation, we're going to simulate the next generation, which takes massive amounts of compute power. Once you've actually simulated the new processor, You do the next step is called synthesis, where you're actually turning it from the high-level description into the actual logic gates you're going to need. You then lay out that actually on the chip to decide the layers of silicon that you're going to make. You actually fabricate those chips, deploy them out into production, and then the next time around, you've got access to more compute power. So this is what we actually try to do in many, many different parts of our Amazon businesses, identify these virtuous cycles and try to make sure that it's this kind of feedback system, that as each part progresses, it makes the overall cycle go faster and faster and faster. And one great way I can show you this is that in about 5 years, we were able to produce 4 generations of our really popular Graviton chips. We launched it in 2018 as like here's our starter model, and it was kind of at the low-end instances at that point. And then successive iterations, the 2, the 3, and the 4, became increasingly capable, more features, but more importantly, more and more power. And the really awesome thing is that at each point, right now I would guess we're probably working on Graviton 5 and 6. That computing, that simulation, is being done on the current generations of the chips. So think about this virtuous cycle. We're going to apply this to software in just a little bit. Okay? So here's what we have. Every time we get better computers, it's going to let us build and run better and richer software. But the thing that is kind of neat about software, we use the software to build itself. We use software to create increasingly powerful and deeper levels of tools and tool stacks. And when I look at it in that context, and I'll go into more detail in just a second, we can look at the AI coding assistants and say, wow, this is it came from nowhere and it's a totally revolutionary technology. That's kind of one perspective. My perspective is we've been building to this point as an industry for decades and decades and decades. So I'm gonna actually talk about that in just a bit. So I see these assistants as not replacing us, but actually making us more powerful. Let's think about our responsibility ongoing as developers before we get into that. So I think we have a couple different responsibilities as developers, but the first is our kind of overall goal. We're supposed to produce code and build systems that meet the requirements. Those requirements might be things that maybe we're kind of informal. We just kind of thought, I want an app and kind of have some thoughts of what that app might be all about. Or maybe it's a little bit more formal and written down. Maybe it came from our customer. But in any case, our ultimate job as a developer, we need to write code that meets the requirements. Along the way, we probably have some desirable attributes for that code. We want it to be correct. We want it to actually behave as expected. We want it to be fast and make efficient use of resources. We probably want to make it maintainable so we can update it more easily in the future. And we somehow want to also make it some good code, which is kind of a little bit more harder to actually identify, but we've all seen bad code and good code. We kind of know what good code looks like when we see it or when we need to work with it. So kind of a little bit of what we're supposed to be thinking about and doing as developers. Okay, now, trying to think about what's been somewhat constant over the years as I've gone from the ones and zeros to the assembly language, to the higher level languages, to the coding assistants. And I think that we can narrow down what we do as developers. We started with some cool idea, some kind of problem that we want to solve. We then think about it some more, do a bit of experimentation. We go from just an idea to an intent, where we've said, okay, I've got this thing I want to solve. I've thought about, sketched out some of the different ways I might want to solve it. Now I figured out this is the way I actually do want to solve it. From there, we're going to take that intent, we're going to turn it into an actual implementation. So ideas of like what language we want to use, or what functions, or what kind of structure, or what algorithms. We're going from just the intent to actually building something, going from the idea into the code. Then ultimately, we're also going to iterate. We're going to say, okay, we built the first one. Along the way, we did some observations, we took some notes, we got some customer feedback. Let's do a little bit of learning from experience. Let's iterate, and we'll do some of these steps of this process again. So idea, intent, implementation, and iteration. Now, what I see is that we started out with we're doing our ones and zeros, our binary code. At that point, the intent was kind of, we had to kind of keep that offline because we're actually looking up all the instructions, saying, okay, this one is 0, 1, 0, 0, 1, 1, 0, and so forth, and we have to specify that directly. We get a little bit higher level to assembly language. Now we're specifying symbolically with instruction names and with symbolic addresses. But then we get even higher level. We're using a high-level language. We're not thinking about instructions. We're not thinking about zeros and ones. We're saying, here is the actual high-level programming language statements that we'd like to do. But each of these is an intent in some way. Now, when I think about the coding assistants, all that we've done is we kind of raised the level of that intent from a high-level programming language to a human language. So instead of a language and we're declaring variables and statement by statement, we're saying start with some integers A and B, add them, and store the result. So this is my vastly oversimplified way of kind of getting you used to this idea that our AI coding assistants, they're just kind of a natural progression of what we've been already doing as developers, from intent to actual running code. So let's look at this a little bit in more depth. And let's kind of think about this whole world of development tools over time. I want to have a very broad, very kind of big circle interpretation of what I want to think of as a developer tool. So I'm going to define a developer tool for today as anything that's made from bits that helps us to do our job better. It could be anything from a language feature to an executable program like an editor or a compiler. It might be a function library or a class library. It could even be some documentation or some training. Again, anything made from bits that's going to help us to do our job. So why am I thinking about tools in this way? Okay, well, tools let us, as Newton famously said, stand on the shoulders of giants. So once one of us has built a tool, we can all adopt that tool, benefit from it, and then we can also compose that tool and use it to build further tools. So we can build on and compose those tools to go even higher level, make things even richer and more powerful. But also, as we think about development tools, they are one of the best ways to take advantage of all these increasing amounts of compute power. And as we do that, the tools themselves grow more powerful. So I won't go into detail on all these, but I kind of think of just some of the different tools that we have benefited from as developers over time. You know, assemblers, editors, compilers, linkers, debuggers, case tools. Anybody remember the era of case tools? No, wow, okay, that was kind of a dead-end branch of tool development. But better things like IDEs, where we took a lot of the previous parts, put them all together into one integrated development environment. Source code control and profiling. When I think about this progression that's played out over decades, the coding assistants are just a really next logical step. I also think of different language features as essentially part of our repertoire of tools for developers. Things that are active at compile time or at runtime. Each of these is something that's there to help us do a better job and to write better code. Another way I think about this is all the different ways as an industry we've invented to encapsulate and package, distribute, and reuse code. Macro libraries, function libraries, standard libraries, class libraries, jars, and even open source are different ways that we build something once, we can get it in front of a wider audience, and then the recipients can use that as a base, and they can start from there and build up rather than starting from nothing. So here's the point of why I've been doing all this. As humans and as developers, we imagine, we build, and we use tools. Then we also use those tools to build even more tools, and that all these different kinds of tools are ultimately good for us, good for the industry, and that we want to respect and take advantage of this progress rather than fearing it. So what happens when we actually mix all of this together? We take the developer tools that we've built over time, the language features, and the packaging, all these things that as an industry and that hundreds of thousands of sharp people have built over incredibly long periods of time. We take all these things, all these bits, we use those to train a large language model, And what do we get? Well, we've effectively taken all of the innovation, all the creativity, all the experimentation, all the things we've learned over the long period of time. We've now got this model that, in theory at least, encapsulates the very, very best of all the things that we've done as an industry. It understands development process and tools and documentation and APIs and our coding styles and ultimately even code. So this is how I like to think of the coding assistants in a historical context, if you will. All the things we've done for years, take those, mix them up into the model, and now we've got this model that's going to make the best of everything that we've done as an industry available to us in our coding assistant. This is a great meme I found when I was putting my presentation together, and just kind of recognizing that fear that we have of, okay, well, if we have these coding assistants, well, we don't really have to need programmers anymore. Well, turns out that every time as an industry we invent something that makes it easier to build, well, it actually attracts more people into the industry. It doesn't say, well, we've got a fixed amount of work to do, so we need less people. It says, well, more people with more different kinds of skills are able to be part of our industry. So let's talk about what's next here. Two of the cool things that I see as really emerging right now, the first are the AI-powered coding assistants. The second one is this idea of formal verification of code. So we'll talk a little bit about both of those right now. Oops. So coding assistants I see as a very logical next step, given everything that's come before. The idea is to make you into a better developer and to go more easily and efficiently from your intent to actual code, increase your efficiency as a developer, and you could think of this as just another tool for your developer toolbox. It definitely is something that is going to, the skills you have, especially your development skills, your code reading skills, your code understanding skills, your expressive skills in natural language, all those skills are going to actually help you to get better use out of the AI-powered coding tools. Formal verification, not quite as well known, but also really powerful. Basically, the idea is that you can mathematically write various kinds of assertions and proofs about the correctness of your program. You can say, make sure that here's my formal specification of a program. Let's confirm mathematically that the implementation is actually faithful to the specification. You can prove programs correct. One of the techniques within this is called automated reasoning. We actually were pretty early adopters of this within Amazon. And when we look at systems like S3 and DynamoDB and IAM, that some of those systems process on the order of hundreds of millions of requests per second, being able to formally verify the logic that in every possible condition and combination of conditions in these systems at this incredible world scale helps us to make those systems more efficient and more reliable. Let's talk a little bit about actual coding assistants. We'll talk about QDeveloper. And the cool idea with tools like QDeveloper, you start out with an intent. And the intent is incredibly high level compared to the way we've been able to work in the past. So my colleague Sanjeev Kumar, and I've got a QR code for his video here, he put together a nice, cool video earlier this year to show how do you use QDeveloper to actually build an entire application from an intent. So let's step forward a bit, and we're going to look at his intent. So those two columns worth of text, this is the entire intent for the program that he specified. We'll look at this in pieces. Here's the top level spec. I want to create a full stack web application for sports event management with the following features. So start out really high level. Specify that on the front end, you'd like it with React.js. You want an authentication system, login page, registration system, and so forth. Specify how you'd like the user interface to be. Modern and responsive with Material UI, navigation bar, a logo, a dashboard. And then here's the heart of the entire system. You want it to do sports event management, a list of events. You want CRUD operations for the events. You want to maintain the event details, the name, the date, the teams, the scores, the venue, and so forth. You want to be able to filter and sort those, validate, confirmation. So again, specifying intent at this incredibly high level, you take that, you hand it off to Q developer. What does Q developer actually do? Well, it goes through that entire specification, and it understands it. It creates a plan. It looks for all the different features within that spec. It's going to write code for you. It's going to create the overall project structure. It's going to go through that entire list of features, put those in the proper files to create a nice, well-structured project for you. It's going to create a summary of the changes. It says, this is all the things I did for you. And then it's going to hand off the code to you, and it says, I've done my best to make this code to represent your intent, and it's now up to you as the developer to review that code and say, does this actually do what I would like it to do? And I'll have a lot more to say about that in just a bit. But that last part, don't underestimate how important that part is. The fact that when you are using an AI-powered coding assistant, you as the developer are still responsible for that code. So we can see here as we go through, it's taking the intent, it's generating code, it creates an entire project structure. And there's actually the QR code for the video, if you'd like to grab that one really quick. So that's I think one of the cool a quick review of Q developer. Now, one of the things I've noticed, and I've been doing some experimentation as I go from country to country and language to language, I've been actually taking the same basic prompt, and I've been translating it into different languages, representing my audience, and then putting it into an AI model and saying, can I express my intent in a language other than English? So this is my basic prompt, really simple prompt. So I use Google Translate to translate this from English to Armenian. I assume that's correct. I couldn't read it myself, but I assume that's correct. So I translated that prompt, and I put it into our Nova Pro model right there, and it was able to actually generate to read my prompt and generate code for me. And I like this a lot because it seemed for most of my career, being able to read and write English was basically kind of a prerequisite to being a developer. And it kind of narrowed the set of available developers to people who could actually at least do some level of expression and comprehension of English. This idea that AI is going to make development more accessible to more people, regardless of the language they speak, I think that's a really, really neat factor, and I think that's a really good thing. This idea that you don't have to, that step one isn't learn English, that you can actually step up and you can actually approach the AI tools in the language that you are most comfortable with. And I've tried this for every country I've been to this year. I haven't actually had it fail yet. So far, so good. All right, let's talk a little bit about formal verification and automated reasoning. The idea here is that it's a mathematically or logically rigorous way to ensure that your code is actually correct. Started out in academia in the 1970s, where it was called proving programs correct. At that point, the proof methods were pretty simple. And unfortunately, the proof was often 5 to 10 times the size of the code. And what that meant was if you couldn't get that much code correct, you couldn't get that much of proof correct either necessarily. But the formal systems have evolved quite a bit. And we're seeing that this is an incredibly powerful technique for making better programs. We're also seeing it's making a pretty quick transition from academia to industry. And we're finding as we build this increasingly complex system, the value of the formal verification grows with that complexity. So you might want to contrast machine learning and automated reasoning. So machine learning starts with a large amount of data. We train that, we generate a model, and based on that model, we ask it to do predictions, which we call inference. And with a machine learning, the model tries to generalize when it hasn't seen some particular kind of input, but it's never going to be 100% correct. We can sometimes see surprises and hallucinations from machine learning models. Now, automated reasoning, on the other hand, we start with very specific information that might be something describing a company policy, a business process, or an operational workflow, maybe a checklist or some code, some kind of a formal specification of some rules and some logic. we translate that into a formal language. And once we do that, we can ask questions about, for example, our code. We might say, does this array index ever go before or after the beginning or the end of an array? Or does this loop ever terminate? Or do these two competing pieces of code that are using locks to make sure that they don't overstep each other's data, do they ever conflict in some way? So automated reasoning lets us answer these very important questions about our code. Okay, so that's kind of like the up and coming future. And the questions I'm getting a lot are, okay, so here's the future. What do I need to actually start thinking about and doing to prepare for it? And I thought about this a bit, and it seems to me that the old way that we thought about development, and I remember early on when I didn't have so now we're kind of in this wonderful time where we've all got computers in our pockets, and we can search, and we're connected all the time, and we can always get that information we need right away. In my early days, getting access to any computer time was very restricted and very limited. And you'd spend a lot of time offline before you got to the computer getting ready. You'd read your manuals, you'd study and study and study again those manuals. You'd write your code out on paper, you'd carefully hand check it to make sure that point when you stepped up to the computer, you get the most valuable possible out of that limited amount of time. But along with that, one of the interesting things was that the reference manual for your languages and your libraries and for your operating system, that reference manual ultimately gave you the full list of capabilities of whatever that system you're using was able to do. So if you were able to understand that entire reference manual, you knew effectively everything you could do. Kind of a digital model. Either the system could do something or it couldn't do something. The new school, powered by these AI models, is kind of an analog model, where we're using these different AI models, and new AI models are emerging almost every week, either a brand new model or an iteration of an existing model. There is no master reference list for any of these models that says, here are the 1,000 things this model can do. What instead we find, every one of these models and every version of them has some capabilities, some strengths, some weaknesses. We can't consult the list to figure that out. We really need to go and experiment and ask questions. Maybe the first set of prompts gives us some pretty good answers. Another set of prompts doesn't work at all. But then we iterate a bit, we experiment, and we say, okay, this is the way that I can prompt this model for this application to get high quality results. So the new AI world really benefits from our ability to get in there, interact, experiment, and iterate. I also am seeing that these AI coding tools have some really interesting implications for the applications themselves. In days past, it took us a lot of work, a lot of energy, a lot of money, a lot of people to build an application. We had to spend a long time writing a spec, a long time implementing, a bunch of testing, and at the point when we finally have the application, we're thinking, we've invested so much time in this application, it's really precious and really valuable now. We're going to need to actually just kind of keep it around for a long time for it to earn its keep. We need to curate it. We're going to need to keep maintaining it, let it earn its value over years and years and years. With the AI tools, I'm seeing something that's actually kind of different. I'm seeing that the app itself is something we spend more time on the prompt than on the application. Once we've got some good prompts, we can almost start to think about these applications as not quite temporary, but fairly short-lived. And instead of maintaining and iterating on the actual code base for years and years and years, we're going to keep those prompts, we're going to keep our understanding of the application current, and we're going to keep rebuilding the application from scratch as the models continue to evolve. So a very, very different way that we can start looking at and thinking about our applications. Now, the application's life might be shorter, but I think that on the other hand, our data is going to become more and more valuable over time. We're going to see that our data is going to span many, many generations of applications. So we can think of our data as more valuable and more precious than ever. We probably want to put more effort than before into having clean schemas, having good descriptions of our data, And in fact, one of the cool techniques I'm seeing some of our customers use very successfully, they are putting an investment in to build high-quality schemas for their existing data. And before they start thinking, well, we've got all this data, but we have some kind of we need to collect even more data, they're using AI to say, how can we get more value from the data that we already have? They literally take all those schemas and they throw them into an AI model and say, here's all the kinds of data I have. What can I actually make from this that I haven't thought of before? Almost like you go to your kitchen and you say, I've got some of this and some of this and some of this. What can I cook for dinner? So people are now doing that with their schemas. So what this says is, let's keep those schemas clean and well describing our data, and we're going to be able to get more and more value out of our data over time. What are the implications for developers? Well, in the old way of thinking, I think that we often had a large development team. Each member of that development team might have some particular set of skills, front-end developers, database developers, back-end developers, and so forth. We put them all together, part of a large team, and everybody gets to use that particular set of skills. I think in the new model that we're quickly getting toward, we're all going to be generalists. We're going to need to be more adaptable. We're going to have to be pretty resourceful because things are a little bit more flexible with our models than in the past. And we're probably, if we're able to be pretty self-sufficient, individuals are going to be able to build very large applications all by themselves. So how do we actually start to think about building our next generation skills? I think that one of the things that we're not quite recognizing, but I want to point out to you, the AI is going to be giving us all this great code, but we don't just look at the code and kind of glance over and say, yep, it looks pretty good, I trust the computer. We actually, as the developers, we are still responsible for the correctness of that code. So a skill that we need to all develop is getting better at learning and understanding from the code written by our AI assistants. I think also, as we start thinking about the fact that we're going to be communicating with our coding assistants in spoken and written natural language, great opportunity for us to refine our spoken and written communication skills, both with our customer or our audience to make sure that we understand them and their requirements, but also with our AI assistant. And again, with our peers as part of our group or our team that we're part of. But again, as I showed you earlier, in our preferred language. So one last thing I've been kind of sharing over the last couple of months, I wrote a post about this earlier this year. I called it Reading Code is an Essential Skill. And I think back to how most developers have been taught over the years. We're generally taught to be creators and versus consumers of code. In almost every case, we start with the blank piece of paper, the blank screen, and we're told, start from nothing and fill it up with content. But with the AI-powered world that we have, it's very, very different. We start with our prompt, we get a whole bunch of code, and it then becomes our job to actually read and understand and validate that code ourselves. And for the most part, I don't think schools have been teaching the understanding of code. But it's kind of funny because in most other creative endeavors, before you get to create, you're supposed to study what's gone before you, right? Before you're going to be a great author or writer, you're probably going to do a whole lot of reading. And before you're going to be an artist, you probably looked at a whole bunch of different things created by other artists. So I think that same technique of consuming a lot of pre-written code, maybe studying the classics of open source, studying code written by your peers, before you think that you're able to actually be a quality user of a coding assistant, I think that's just actually something really important. And I would actually encourage you to sign up for an AWS Builder ID as well. If you don't have one already, this is a great way for you to get kind of tied into AWS. You get access to course materials, you get access to Q Developer and so forth, all with your Builder ID. We do encourage you to sign up with your personal email address versus a work address. The thinking is that your Builder ID should actually go along with you throughout your AWS career. And so we want to continue to add value to your experience through the Builder ID. And with that, I think I'm just about out of energy and out of time. So would love to take any final questions you might have. If it's a one-on-one question, always happy to I'll be here and always happy to talk offline as well. All right, got a question there. We'll probably need a microphone.
Yeah, that's fine. So this is a short question. Those AI models, processors, what size are we talking about?
In terms of what metric?
Regular size, megabytes, gigabytes.
Oh, I actually don't really know. I generally see the models expressed in terms of billions of parameters and tens of billions of parameters, but how that translates into actual file sizes, I know that you can actually download what's called the model weights, and for open source models, they're generally in the order of tens to hundreds of gigabytes, I believe. I'd have to look a little bit more closely to see. A lot of these are, for AWS purposes, these are just kind of stored in the cloud, and they're just there and available for your use. So now there are various things that people will do to the models to compress them for different use cases. Like there's this process they call quantizing, where you're going from like models with 32-bit floating point to 8-bit floating points to even smaller numbers sometimes, where you can actually sometimes shrink those models down to run on like desktop devices or even dedicated hardware sometimes. Oh wow, lots and lots of good questions. Okay. Yeah. I hear you.
So I had to write my question down because you don't get to ask Jeff Barr a question every day. I just wanted to make sure I got the question right. So Jan LeCun, like the dude from Meta, he's been going around recently kind of sharing his hot take on Gen AI and LLMs, how he believes like they're limited, they'll die off in the next year or two. And basically he's saying they're limited because they'll become obsolete. He believes the future of AI lies in systems that build internal models of the world, learning on observation and reasoning like humans, with some like continuous memory, rather than LLMs that are kind of trained on sets and then maybe plugged into a RAG. I guess like what's your perspective on where they're headed, and if LLMs really are, Gen AI as we know it is kind of limited, or if AWS is looking into, I guess, the next generation, as you've been discussing, of like what that AI will look like, not tomorrow, but in a year or two.
Wow, that's an awesome question. Let's see. So I think we have to realize that this whole phenomenon of AI-powered coding assistants is brand new. We're talking 2 years, 3 years, really, since these have become really even prominent. And like any new technology, it's going to take iterations by the industry before it reaches its like ultimate polished state. Now, I do like that idea that Jan expressed of the fact that it is going to have more internal knowledge, that maybe we're going to always have the generic model, but then you would actually have a separate model that is effectively trained on like your organization or your industry. So I think there's a lot of pessimism expressed in what he has to say, but we've got a lot of smart people working on these problems as an industry. So I don't think we're ever going to reach some kind of like a sudden dead end or realization, and we'll say, I'm sorry, but none of this actually works. Like I see people getting such value from all these tools every day that I think we're headed in the right direction. Do we still have some surprises ahead of us that will like suddenly make everything we've done to date say, wow, that was so simple and plain, now we've got this amazing cool new thing? I think there's still a lot of room for innovation coming out here. So I'm going to be pretty optimistic based on what I've seen here so far. And I see so many people getting great value. I see within my own family, both of my sons actually have applied math degrees, and they're both, one of them's a Cursor user, one's a Windsurf developer. I watch the kind of things that they do on an hour-by-hour basis, and I watch over their shoulder, and it's like, this is nothing like what life was like when I was building stuff with code. And like to go from zero to complex running applications in a couple hours sometimes, it's pretty mind-blowing actually. So I actually think we're heading in a pretty good path here. But great question, and something we'll have to see how that all plays out. Oh man, lots and lots of hands. Okay, let's see. You already had one question, so we'll talk one-to-one later. Okay, let's see next. Where's our next? Okay, there you go. There we go.
Okay.
All right.
Thank you for the presentation. So let me step back, and my question is a little more general because I'm not a coder, but I'm involved in lots of discovery and pre-sale stuff. So since we are using lots of AI and everything is AI enhanced, and we are doing lots of discoveries there, AI can hallucinate a lot. It doesn't matter what model it is. I want to know what's your approach to fact check some of this stuff, because if you don't fact check and don't check the resources, AI can give you some metrics, some statistics, some numbers that they are not correct, and based on that you will inform some customer it will be incorrect, and it will have some devastating outcome. And I believe if we don't do such a thing and we don't kind of stop, pause, and do some fact checks, it might cause very big issues, and we might be the last generation that are fact checking this sort of stuff and not trusting the AI. So do you have any mechanism, any process there to do this? And what's your take on this?
Certainly. So of course, as we train the models, we're always trying to put more high quality data into the models. The very, very nature of the way the mathematics works does say that hallucination is possible. But what we try to do with our own models, our own systems, we do something we call guardrails that are on the input and the output, that are the ability to actually check on the input and check on the output side for some level of reasonableness. There's also been some really interesting work with formal logic to try to actually kind of prove, to kind of combine the two things I said, like using the formal logic on the output of the model to actually say, is this actually reasonable, and is this correct? But I think we also have to look at all of these models, like any other kind of a tool, and say, it's only as good as the user. And it's still up to all of us to say, okay, I made a request from this AI, something came out, and then always be able to exercise human judgment and say, did I get the right answer from this? And although that might seem that you're repeating work, my experience has been that the process of verifying the output is a lot quicker than actually creating it yourself from scratch. I would expect that at some point we might even see interesting systems where you might use several different models in parallel to almost try to replicate the results. Like at the same time, sometimes like one researcher will do some kind of like a new experiment and get results, and then there will be peer review to say, can we actually reproduce these results? You can imagine a way that you might use multiple models to say, okay, are we getting consistent results? Not necessarily the same results, but consistent results from different models. So certainly something to be aware of, but something that the industry is very, very much focused on as well.
Let's take one more question.
One more, okay, right there, close to you.
Hello? Yeah. Okay, so thank you very much for your presence here. We are really blessed with your presence here. And thank you for your visionary speech. And my question is more about the security, privacy, and ethics of usage of AI. So you stressed in your presentation that the final responsibility to use the code is on a developer's shoulder, right? But however, during this development process, when user talking with AI in some language, AI itself taking so much private information and maybe secret information, confidential information, commercial secrets from the users. And my question is how Amazon is using this?
Correct.
And is there any regulation in regards of ethics, privacy, and security? So
Certainly.
thank you very much.
Okay, that's a really important topic, and I'm really glad that you asked that. So we do not use any customer data or prompts to train our models. We keep those very, very separate, and any prompts that you enter are used only to generate the response, and they're not logged and kept and used for further training. There's a whole concept, and we have actually like a page we call it Responsible AI that actually identifies all the different guidelines that we have set for ourselves to make sure that we're treating your data safely and securely. Much in the same way that any other kind of data that you would store in the cloud, it's never processed or scanned in any way. That's your data. You have full control of the data. You have the ability to encrypt that data any way you'd like. We never look inside it. We don't do anything to it. We just store it, make it available to you. The data that you would enter in terms of prompts and so forth, again, that's your data, not something that we have any claim to or any desire to look at in any way.
So is there any policy, internal policy within our Amazon AI to use AI in an ethical way? So because you know it's a fundamental problem from all of AI providers.
There actually is, and so we call that whole collection, we call it Responsible AI, and there's a web page you can find on our site that has all the, I don't have the details committed to memory, but yes, it actually is that, it's something we take very seriously.
Thanks a lot.
As Armen said, it's not every day we're seeing Jeff Barr here on the stage in Armenia. So probably we can accept one more question if you don't mind.
Sure.
And then best question, you need to choose. There are a lot of questions.
Thank you, Barr. Since we started to touch on sensitive topics, so one more probably. It's not a secret everybody is concerned about AI, also the software developers. So there is this concern, we may lose our jobs, etc., etc. Having this said, in any case, we have to embrace that, we have to face that. What would be your main advices on this to software developers, what they should do in first three things, let's say this way?
My main advice would be start using these tools now. Get some experience with them now, and don't be the last one in your organization to get experience with it. I found with over many, many years in my career, I've always tried to find something that's new and get some experience with it before most people even knew it existed, and not be the expert necessarily, but get some sense of this is what it is, and this is what it's good for, this is maybe what it's not so good for. And then if you're really lucky, at some point the boss comes in one day and says, hey, we're going to be doing this new thing. And most people are like, what is he talking about? And then one person's like, you know what? That's cool. I've already spent some time studying that. I know more than zero about this. And if that happens to you just 2 or 3 times in your whole career, you get to step ahead and you get to actually make some great progress. And so being that early adopter and getting a little bit of experience with everything that's new, I've found really pays off incredibly well in your career. So I would say embrace the future, embrace change, get some experience. It almost doesn't matter which model, which tool. Some experience with any tool is going to get you out ahead.
Exactly. It's not that scary that some of us are thinking, probably.
You know, I remember probably 30 years ago, my father handed me this business magazine, and it said, computers will soon write all the code. And he basically questioned my career choice. And he said, you know, computers are going to write all the code. Are you going to have a job in a couple of years? And he was honest and sincere about it based on that magazine title. But you know what? The industry changes, the industry moves forward, and it's up to us to be part of that change and to move forward with it.
Thank you. Thank you, Jeff.
Choose one of the questions.
Oh, choose one?
Yeah.
Okay, I'm going to have to choose the one over there that was written out. So the one you had on your phone.
Armen.
Yes,
here.
yes. Where'd you go?
Here he is.
Yes, okay.
Yeah.
There we go.